2 minus beta 4 divided by, this is simply we can just take it down, we now divide. And similarly C value is also given. What are the value C here? C is given by C is equal to root of K1 squared, K2 squared plus K3 squared, K4 squared minus 2K1 K2 cos of beta 2 minus beta 4 divided by K2 squared minus K2 squared divided by K2 squared minus K4 squared. So this is about the analysis of the amplitude comparators. So finally what do I conclude? It is nothing but it is a circle with the distance of C from the origin, right, having a radius r, right, and we are going to conclude that whenever the signals S1 and S2, when I take the values of S1 and S2, if it is S1 to S2 within your circle, you say that the relay is going to operate, and when it is crossing a boundary, the relay will not be operating. So this is the condition for the amplitude comparator, and this is how we have to do the analysis of amplitude comparators. So next we have phase comparators. So what are things we have seen? Amplitude comparators. What first we have done? We have considered two signals. What are they? S1 and S2. These are two input signals which are derived from the current or the potential transformers of the power system, right? And in many cases we know that the signals are to be mixed up, right? So the current transformer and the potential transformers or signals are to be mixed up. So they are using a mixing device in order to mix up the two signals, and we have two values of S1 and S2. The first expression of your derivation, please go through that. S1 is equal to K1P plus K2P, K2Q, right? And similarly S2 is equal to K3P plus K4Q. And after mixing, we have S1 and S2 with the constants K1, K2, K3 and K4, and with the real part of cos theta 2 minus 5, imaginary part of sin theta 2 minus 5 for S1, and for S2 we have the real part as cos theta 4 minus 5 and the imaginary part as sin theta 4 minus 5. And what are the, now coming to the analysis of the amplitude comparators, what is the first step we have done now? We have taken the values of S1 and S2, and we are going to tell that whenever the modulus of S1 is greater than modulus of S2, the relay is going to operate. Is it not? So to find the condition or the threshold condition at which condition the relay has to operate, I am going to equate S1 and S2 in order to arrive at the condition of the operation of the relay. So we have taken different steps here. So S1 in the left hand side and S2 in the right hand side are being equated, and we have proved out all the constants by dividing that equation by K2 square minus K4 square by P square. So when I am deriving that, dividing that equation, finally we had cos of theta 2 minus cos of theta 2 minus 5 and sin of theta 2 minus 5. I am going to apply the principle of, what is that, cos A cos B plus sin A sin B. Substituting that in the values and equating the constants of A0, B0 and C0. Finally we have arrived at the third equation of your derivation, that is, what is that, Q square by P square plus 2Q by P A0 cos 5 plus B0 sin 5 plus K1 square minus K3 square by K2 square minus K4 square. So finally what do you conclude? This represents a circle in the beta plane with Q by P cos 5 as your x-axis and JQ by P sin 5 along your y-axis. So which is nothing but, I have drawn this circle. I think you can see that the circle is from the origin at a distance of C with the radius r. So what are the values of the radius in C? Just we have taken the values there. What is that, ma? K2 square, radius r is equal to root of K2 square, K4 square minus K2 square, K3 square plus minus 2K1, K2. So now minus 2K1, K2, K3, K4 cos of theta 2 minus theta 4. It is K2 square plus K4 square. It is plus K2 square K3 square minus 2K1, K2, K3, K4 cos K1 square, K2 square plus K3 square, K4 square minus 2 K1, K2 cos of theta 2 minus theta 4 divided by K2 square minus K4 square. How to remember this equation, these two equations? Please go through the equations. How can you remember? I think the denominators are same in both the expressions. Is it not? K2 square minus K4 square is same. And regarding to K1, K2 again, here what is missing? K1, K2, K3, K4. So this term and this term are common in both the expressions. So when it is common, you can remember only the denominator coming here. What is that? K1, K2, that K2, K3, then again K3, K4, K2, K4. And that can remember. So that is how values of the radius of the circle and the distance C from the origin is determined for the analysis of amplitude comparators. Any doubts, students? Radius R, then constant C, operating point is S1 by S2 should be within your circle. Beyond the circle, you say that the relay will not be operating. So this is something called the representation by using your RX diagram. I hope it is clear. So remaining we'll see in the next class.